All right, let's talk about something we've all experienced. You're asking your phone for directions, or maybe they're listening to an AI-read audiobook, and then it happens. It says something just plain weird. It's a tiny little glitch, but it completely shatters the illusion, right? Well, today, we're going to pull back the curtain and find out exactly why that happens. I mean, you know exactly what I'm talking about, don't you? That moment when a perfectly normal sentence gets mangled into something just bizarre. It's super frustrating, and as it turns out, it points to a really complex problem that's kind of been hiding in plain sight. Okay, here's a classic example. The written text is, "It's the 17th century." Seems simple enough, but what you might hear the AI say is, "It's the 17 degrees century." I mean, what? It's so close, but also completely wrong. So what's really going on here? And here's the surprising part. The problem isn't actually with the AI's voice. It's not a speaking problem. The real breakdown happens way before it even makes a sound. It's a reading problem, a fundamental misstep in that first crucial stage of translating written words into spoken ones. This whole process has a name: text normalization. The best way to think about it is like a little translator living inside the AI. Its only job is to look at all the weird stuff we write, numbers, dates, symbols, abbreviations, and figure out how a human would actually say it out loud. It's the invisible, unsung hero behind every AI voice you hear. So if this is so important, how has everyone been dealing with it until now? Well, the old way, let's just say it was an absolute beast of a task. We're talking a colossal amount of manual labor. Imagine this. For every single language, engineers had to sit down and hand code thousands upon thousands of strict, rigid rules. A rule for dates, a rule for currencies, a rule for street addresses. You name it, there was a rule for it. As you can guess, this was insanely expensive, it took forever, and it was a total nightmare to scale. And this quote from the research paper that inspired this whole thing, it just hits the nail on the head. The same surface form can be normalized differently depending on context, and that is the absolute killer flaw. A simple, hard-coded rule has no idea about context, and that's where the whole system just falls apart. And check this out, because this is a perfect example. In Italian, if you're talking about history, 17th is pronounced diciassettimo, which means 17th. But take that exact same symbol and use it in Spanish to talk about a floor number, and it's pronounced 17, 17. See, a rigid rule would totally fail here. Context is absolutely everything. Okay, so if the old way of building voices with a million rigid rules is broken, what's the alternative? Well, this is where a brand new approach called PolyNorm comes in and completely changes the game. It says, forget the giant clunky rulebook. Instead, let's actually teach the AI how to read with understanding. The core idea here is, well, it's kind of revolutionary in its simplicity. It just throws out that entire rulebook. Instead, it uses a powerful large language model, an LLM. Yeah, the same kind of tech that powers things like ChatGPT. And here's the kicker. It teaches this super smart model not with thousands of rules, but with just a handful of really good examples. This technique is called few-shot prompting, and it's basically a simple three-step recipe. First, you give the AI clear instructions. Tell it what you want it to do. Second, you show it a couple of examples of the task done correctly. And third, you just let it go. The AI is smart enough to see the pattern in those few examples and then apply that same logic to new text it's never seen before. It's pretty amazing. So, the big question is, does it actually work? Is teaching an AI really better than programming it line by line? Well, the results aren't just impressive, they're a genuine leap forward. Let's just look at the numbers for American English. The old-school, rule-based systems had a word error rate of nearly 10%. Not great. But with PolyNorm, that error rate gets slashed by more than half, plummeting down to just over 4%. That is a massive improvement in accuracy. But honestly, the numbers only tell part of the story. The real magic here isn't just about making fewer mistakes. It's that the AI is starting to develop this nuanced, almost human-like grasp of context. Let me show you exactly what I mean. Okay, so when PolyNorm sees a sentence like, the score was 3-2, it knows that the dash means 2. So it says 3-2. Perfect. Makes total sense for a sports score. But what happens if it sees that same little dash in a totally different situation? Well, when it sees a phone number, it knows the dash is just a separator you're meant to ignore, so it reads out the digits individually. Think about that for a second. A rule-based system would need a whole separate, complicated set of instructions just for this. PolyNorm, it just gets it. So as you can see, this is way more than just a cool tech demo. A breakthrough like this has some serious, real-world implications for how we develop and experience AI voices from now on. So what does this all mean for us? Well, for one, development gets way faster. We're talking about replacing months of tedious engineering work. It's also way cheaper because you need less human intervention. And here's the really big one. It makes it so much easier to create high-quality AI voices for so-called low-resource languages, the ones that don't have billions of speakers. The end result? Better, more natural, and more consistent AI voices for everyone. So, when you step back, you realize that by teaching an AI to read, instead of just follow rules, we're doing more than just making voices sound better. We're making this incredible technology more accessible to the entire world. We've just seen how AI can learn the subtle, context-driven rules of our language that we all take for granted. And if a barrier this fundamental can be overcome this elegantly, it really makes you wonder, doesn't it? What's the next one?